Welcome back. Welcome to my channel. This is Further Solutions Academy. Um, this this video, I'll be walking you through second order differential equation part 1, which is introduction to second order. That is what I'm working on in this video. Now, this video is a content of, I'll be having number 1, definition of second order. Number 2, concept of wronkian to second order. Concept of or application. Let me just say application of wronkian. Application of wronkian to second order, and problem on what? On wronkian. On it means I'm working on problem on wronkian. Okay. This is Further Solutions Academy. Further Solutions Academy. Encourage us more. Help us to academy. Encourage us more. Help us to share our video and also subscribe to our channel. Help us to share and subscribe. I'll be walking you through this particular one. Now, let's move on to definition of second order. Now, before you watch this video, try to watch first order. It's very, very important. Now, in the first order, we have something like dy, the x plus what? D naught, and plus what? M of x equals to what? A, equals to small a. Now, this is what? First order. Because the degree here is what? Is 1. Sorry, the x is 1. Now, the highest degree here is what? Is 1. But when the case is now changed and is no more on what? On 1. That is what you mean by second order or more orders. Now, if I can say that what? D squared y all over what? D squared. It means this is a second order. Why this one is a first order? I've worked on this on previous ones, which is first order, and I've given a lot of methods that can help in solving the problem, and so on and so forth, like a Bernoulli, exponential, and so on and so forth. Now, but if I'm now talking about second order, it means I'm talking about the order are more than 2, are more than 1, are more than 1. Now, it may be 2 and above. Now, second can be 2 and above, which is my second is that. Please don't forget that. It's very, very important. And this particular problem, there are 2 cases. The first case, we call it homogeneous, and the next one is called non-homogeneous. Now, if it is homogeneous, my homogeneous will be what? Dy dx squared plus what? 3 x dy dx plus 1 equals to 0. Now, this is called homogeneous equation. This is called what? Homogeneous equation. This is called homogeneous equation. Because of what? It's equal to what? Is 0. My d here is what? Is 0. Is what? Is 0. But when the case now change, I have the y, the x squared plus 3. Okay, let me use 9x dy all over the x plus what? 3 of x, or 3 of x, okay, plus 7 equals to 8x squared. Now, this is called non-homogeneous. Non-homogeneous equation. That is what we are going to work on this particular method. Now, this one will be maybe part 2 of second order, while this one will be part 3, and so on. This one is very wide. Also, they are both wide, but this one should be able to take a 30 minutes video. Okay, let me now work on wronkian. Now, wronkian, I've explained wronkian in one of our video. If you please make sure you watch that wronkian. Wronkian, it means we are using our determinant to achieve some things on what? It might wronkian if I have a function of what? X is equal to 3x squared plus 5 plus 5x minus 1. And S1, S2 is equals to what? 3 S squared minus 1. Now, if I should achieve my Roscan is always equals to determinant of what? X, Y, S1, Y1, Y2, and Y prime of 1, Y prime of 2. Now, when I'm talking about my Y prime is given as what? Dy all over what? The x. That is, I'm doing the second derivative. I will differentiate this. That should be mine. Now, after achieving this, that should become a what? A terminant, which is I have my y and y1 and y prime 2 and minus y2 y prime what? 1. That is all I'm talking about. That's what I'm using on this video. It's very, very simple. Now, but make sure you view, I won't have the time to explain that deeply now. Make sure you view our application, our higher derivative, Roscan. It's on the differentiation part 4. Make sure you view it. Now, if I'm talking about Roscan, that is all about Roscan. Now, I want to use a Roscan. Before we do that, I will show how we use Roscan how we prove Roscan, how it is being proved on our what? Now, my Roscan, it always equals to, now, for instance, now, I want to achieve my Roscan. Now, but before we achieve our Roscan, now, the second, sorry, how to note, the second, the concept of Roscan, Roscan, this is R. Roscan, the concept of Roscan can be applied to the solutions of second order differential, sorry, let me use second order differential equation. Sorry, I don't have time. Second order differential enough. So, if a solution of that differential equation, if the differential equation is known, that is if y prime is a solution of differential equation now, solution of differential equation, the Roscan is applied. The Stockner application. The Roscan applicable to obtain independent independently solution order. Solutions. Now, if I have something like this, solution of second order. Now, second order. Now, this is all about Roscan. I've explained the meaning of Roscan. That Roscan, if my when you do my Roscan and you have is equals to 0, and if my Roscan is not equals to what is 0, I've told you the meaning of this. One is what? Independent. Okay. Because of that, I would like to work on now if it is equals to 0 and equals to 0. Now, okay. If it is equals to 0, it means what? Independent. Linearly. Sorry, let me use the word linearly. Linearly dependent. dependent. But if it is not equal to 0, it means linearly independent. I've explained that on our previous video. I've explained that. Now, okay, that's all about wronkian. Now, if I want to use my wronkian very well on this, let me use my wronkian now. I want to use to achieve some things. Sorry to cause some problem. Now, let me prove wronkian for you. How it's being proved. Now, with the help of my wronkian, I want to prove this for you. Now, my wronkian. Now, for instance, I have consider the following there. Consider the general differential equation. General differential equation. Now, it means I have y prime prime plus p of x y prime q of x equals to what? 0. Equation 1. Now, that is what is my wronkian. Now, I have this particular equation, which is considered as equation 1. Now, I now have what? My wronkian all over what? Y prime 2, my y2 squared. Now, this is what? Don't forget that my wronkian, it will be equals to y. This is prime 1, 1, 2 prime, 2 prime 2 and determinant. That is my wronkian. Now, if I have this, it means my wronkian is equals to this. With the help of that, I will achieve something like this. Y. Now, I'll be having y prime, y1, y2 prime minus 2 y prime 2 divided by what? Y squared 2, 1. Now, that is what I need here. Now, I think this is my wronkian. My wronkian is going to be equal to this. Now, if I should have this, it means I'll be having what? My, don't forget that I will be now be what? My wronkian, it will be equals to y minus y2, y1 prime. That is my wronkian. Now, since my wronkian is equals to this, I will now move on by having, if I do differentiate my wronkian prime of x, it means I'm looking for second order. I want to differentiate this prime. It means I'll be having what? To be equals to y prime 1, y2 1 plus implicit. It's an implicit function. This one will be what? y1, y prime prime of 2 minus, I'll be having, this one will be what? Y prime 2, y prime 2, 1 rather, minus, which is, if, let me just introduce the brackets, plus, this one will now be what? y2, y prime prime of what? Of 1. Now, that is what I'm going to have for this. Now, since I'm having that, I can now move on by having, I will be having something like this. Now, if I have this, it means I want to work more on this particular problem. I will be having, normally, I'll be having, if I should open brackets, this one will move out. I don't have that, sorry. This one will be minus. Okay, this one will be minus. Now, if I open bracket, it should be minus. Now, if I should make use of my sign, it means this and this will cancel out themselves. This will move out this, which is, it will be left with my what? My wronkian prime, it will be what? Y prime, y11 of 2 minus what? Of 2, y prime prime of what? Of 1. Now, y prime prime of, my prime means second order. My prime one means what? Second order. Now, I will now move on by it what? Now, if y prime of x satisfy equation 1. What is my equation 1? Therefore, this is my equation 1. This is my equation 1. It means I will now be having wherever I have my y prime, it will now be what? Now, satisfy equation 1, which is my equation 1, it will be what? It will be with what I'm having here. Hope you know that with what I'm having here, I can turn it to what? Y2 squared of what? Wronkian. Now, y2 squared of what? Of Wronkian. It means I can answer that what? My it will now be equals to, it will be equals to, it means my 1 prime of x, it will be equals to, now back here, it means I'll be having y2 bracket of what? My equation, which is going to be what? Okay, it will be equals to y prime prime plus p of x y prime plus q of x equals to what? Equals to 0. Equals to 0, which is equals to 0. Now, I'll call it equation 4. Now, at this point, I can now move on by having my what? I can now expand my. Now, if I should expand, I will expand this way. This one will be what? Y. This is Allen square. Sorry, this is Allen square. I'll be having y2. Okay. Since I have this, I will now be having this. Now, this is my y2. I want to test on my y2. It's going to be my y2 bracket of I have y prime prime plus p of x y prime plus q of x equals to what? Equals to 0. Now, I think I don't need that 0 for now. I'll move on to the y1. Y1 bracket of what? Y prime prime of plus, this is going to be what? P of x y prime. Okay, P of x y prime plus what? Q of x. Now, if I should open the bracket here, my bracket here, I'll be having y prime, y2, y prime prime plus p of x y prime y2 minus plus q of x y. And also I will be having what 2, which is going to be y1 y1 of what plus yes, this is what I'm having here, plus what? P of x y2 y prime of y1 plus what? Q of x of y1. Now, at this point, I can now decide to what? To equate it, which is I'll have these are equal to 0 and also equals to 0. If I subtract the two equations together, what will I get? It means I should subtract the two equations together. I'll be having now it means I'll be having this particular one. It will be what? Y2 y prime prime minus y2 y1 prime prime. Now it means this on this side it will be equals to Wronkian. Now it means I'm having my what? My Wronkian. Now if I should have this and this together, also it will give me something very good. It will now be what? My Wronkian is equals to, now what I'm going to have here is we're having y2 y1 and prime prime. It means y prime prime, it will be what? Out of the bar. Now it will be this one will be, sorry, I've explained that following I'll explain the other part. Now it means I'll be having, okay, there's a mistake somewhere. I think I didn't make this code is too small. This manage hospitals. Okay, I have to make, let me quickly recount it again because it's not well explained. Okay, sorry for that. And I have to just, okay, understand. Let me start over again. Now, if, please note here is, if y1 of x satisfy equation 1. Now, what's going to be my equation 1? It means what? I have what? Y. This one will now be y2 bracket of what? Y prime prime plus, this one will now be what? P. It will now be P Now p of x of what? Y prime minus, plus, it will be what? Minus q of x y1, close bracket, equals to what? Equals to 0. It means I added something to this. It's the same. This one, this one, this one. They are all in 1 and also 1, 1. And also, if y2 of s satisfy equation 1, it means what? I'll be having the same thing. It will be what? Y1 of what? Y prime prime plus, this one will now be what? P of x of prime of what? Of 2 plus q of x of what? Of 2 equals to what? Is 0. Satisfied. Now that is what I mean there. I think it's well clear, because this is, that one is not very clear. Now since I have this, if I should open my bracket, I will have something this way. I'll be having, if I open my bracket, I'll be having my y2 y prime prime plus y prime prime of what? Of 1. Y prime prime of what? Of 1. Sorry, of 1, to be 1 prime of 1. Sorry, this is 1. This is, sorry, I'm working on 1 here, I'm working on 2 here. Now, y prime of what? Of 1 plus, I'll be having p of x and y prime of 1 and what? Of y of 2. Now, plus, this one will now be what? Q of x, y of what? Of 1, y of 2 are equals to 0. Now, and also, if I have the same thing here, I'll be having y of what? Of 1, y prime of 2 plus, this one will be what? P of x, it will be what? Y prime of 2, y, and also plus q of x, it will be y2, y1 are equals to 0. Now, this is what I'm having here. I can now say that what? I want to minus the two equations together. I want to subtract them together. Let's see what will happen. Now, if I subtract this and this, I'll be having my wronkian prime. I think I've shown my wronkian prime that time, which is, this is my wronkian prime. This is my wronkian prime. Sorry, my wronkian prime. Now, I've shown it here. Now, at this point, my here, it will be plus, this one will be what? P of x. When you add up this, when you subtract these two from here, it will give me what? It will give me my wronkian, which is going to be what? Y1, Y2, abi? Y1, Y2, yes, prime, and what? It will also move on to that level, which is going to be what? This and what? And this, which is going to be plus P of what? Wronkian of x. Wronkian, let me just say Wronkian. This one and this will be 0, equals to what? 0. That is what I mean. Now, at this point, at this junction, I've achieved this. Now, once I have this, I can now say what? My Wronkian prime from here now. My Wronkian prime can be equals to what? P of x of what? Of Wronkian. P of x of what? Of Wronkian. Now, if I should work on my Wronkian, that means my Wronkian, it will be what? Now, my Wronkian, I can say what? If I differentiate, take away this one now, it means d of Wronkian all divided by what? The x, it will be equals to what? P of x Wronkian. Now, what am I doing there is that I'm just removing this, I'm differentiating this a bit to take away, to drop down the what? The integral of what? Of Wronkian. Now, once I have this, it will be equals to what? Of that. Now, I can now cross multiply, which if I cross multiply, I'll be having P of x d of w equals to what? P of x of wronkian of the x. Now, I can now say that divide all both sides by what? By wronkian. Also, I'll be having wronkian here. This will cancel this. This is going to be minus, sorry. This is going to be minus. This is going to be minus. Plus is moving there. Now, since I have this, please permission to on. Now, I can now say that what? I can now move on by having, I will be having what? D of what? W all over what? All over wronkian equals to what? Minus P of x dx. Now, that's what I'm having here. At this point, I can integrate. If I integrate, I can integrate. Now, if I should integrate this function, it means at this junction, if I should integrate, I'll be having my, okay, before I introduce my integration sign, before I introduce my integration sign, now, I can say that what, okay, let me integrate, I have no problem. Let me integrate. If I should integrate, I'll be having what, my ln wronkian equals to what, minus P of x dx. Now, it means if I should do my ln, if I should use my application of what ln, it will be what, e equals to what, exponential of what, minus integral of P of x dx. That is what I'm talking about here. Now, since I have this, I can answer my wronkian of what, of this. Okay, my wronkian of this, I can now move on by having y of 2 all over what, y of 1, which is of prime, it will be equals to what, of wronkian of what, of y squared of what, of y. Now, since I have this, now I can answer that what, if I should integrate this, I integrate this, this one will what, the prime will move away from the situation. The prime will what, will vanish. It means I'll be having y2 all over y1 equals to integral of what, wronkian all over y square 1 with respect of what, the x. Now, since I have this, now if I should cross multiply, I'll be having okay, if I should cross multiply, I will have if I multiply both sides by this, I'll be having y2 equals to, because this is what I'm working on. I'm working on second y2, which is, I have y of what, I have y1 of what, wronkian of what, of x dx on 1 dx. Now, since I have this, I can answer that what, which is that is my what I'm looking for. That is my second function of what, of my wronkian. Now, that is what I'm looking for. Now, I can use this. See, let me apply it to real life situation. Now, I want to apply it to real life situation. Okay, I want to apply it to real life situation. Look at this formula. This formula is very important at this point. Now, I have a problem this way. I have this type of problem. Now, okay, I have this type of problem here. If x y prime minus 1 plus x of y prime plus y equals to 0. Now, I want to achieve where my y2 is equals to of e of x. Where my y2 equals to e of x. Now, we want to achieve by what? My y1. My y1 is equal to, now we are looking for what? Y2 on question mark. That is the meaning. Now, my y2 is on question mark. How do I achieve it? This first thing is what? I divide, okay, solution to this problem. I have x prime minus 1 plus x of y plus y equals to 0. Divide all by what? By x. Once I divide all by x, I'll be having what? All by x. This one will be all by x. Now, since I have that, it means my p of x, it will be equals to what? Minus 1 plus x all over what? That is my P of x. Why my Q of x? My Q of x is everything that is what? Here. Now, I will now move on that my wronkian is equals to my wronkian is equals to exponential of what? Of integral of what? P of x dx. Now, it means I'm working out my wronkian is equals to exponential of what? 1 plus x all over 2, 1 plus x all over 2. I'm also having minus. Okay, let me leave this minus for now. All bracket of what? The x integral. Now, if I should integrate this, I'll be having, which also implies e raised to power what? Ln x plus x. Yes, because this is going to be what? Sorry, this is x. Yes, 1. Why are you patient? Okay. Hope you know that this is fraction. Now, since I have this, I can now move on to this will produce what? X e of what? Of x. S e of what? Of x. Since I have that, I can now move on by having my what? My function of what? Of e of x. I will now move on by having my y2. My y2, it will be equals to my y2 of x, it will be equals to e of x, which is my y. Let me before we move on. I will not use my formula. My y2 is equals to what? E of x. Now it means my yes. Now it means this is the formula I'm using now. This is the formula I'm using. Now it means my y2 is equals to my y1 is what? E of x. My wronkian, this is my wronkian, which is going to be what? Integral of x e of x. Now my y2 square, it will be what? Multiplied by 1 all over what? e 2x dx. Now normally this we cancel the square here. I'm having y2 equals to e of x integral of x e minus what? S dx. Now that's what I'm going to have. Now if I should have this, if I should integrate, I will be having y of 2 equals to e of x. If I should integrate the bracket, I'll be having it will be by parts x minus e of x minus. Now yes, and also I'll be having minus e of x minus dx. That is going to be, I'm working on my parts now, which is going to be 1 will be here. Now since I have this, I close my bracket. I'll be having e of x minus e of x plus. Now if I should differentiate this, I'll be having minus again e of x plus what? Plus k. Now which is going to be what? My y2, this is equals to my y2. Now my y2 will be equals to e of x minus what? X e of x minus e of x plus what? K. That is my y. Sorry, my y2. Okay. Sorry, this is bracket. This is bracket. There is a problem somewhere. I've made mistake somewhere. Sorry, this is a mistake somewhere. Now this one will be what? This and this. It will be minus x. Sorry, this and this. It will be minus x. It means s. Yes, upper. This also. Okay, this one will be plus what? E of integral of what? Of x, which is going to be what? The x. Now, which is going to be my y2 will be my y2 will be minus x plus this one will be what? E of x minus e of x minus plus what? K, which is going to be yes, and if you integrate that, which I will now be what? Minus x plus e minus x, which is minus 1, sorry, to be minus 1 this and this. Yes, now it will be minus 1. Now, yes. Yeah, it will be minus 1. Okay. And also, I'll be having what? Plus k of e of x. That is my y2. That is my y2. That is my y2. Plus k of what? E of x. That is all about. Now, with the help of this, can you see how my Roscan comes to what? To apply it to real life situation here. Now, this is further solution academy. Further solutions. Further solutions academy. Encourage us more. Help us to share our video and also subscribe to our channel. Help us to share and what? Subscribe. Thanks for watching. Thanks so much.